So we're in math 321. And I don't know, what is it, day 10? Think so. Nope, we're on day 11. It's Tuesday. We've had every single day. Day 11. Lecture 9. And we're going to work on set builder and interval notation. Okay, so let's say set A is X is greater than or equal to 4. And I'm going to say set B is X is less than or equal to 7. And we'll say set C is X is less than -2. Have we covered the inequality symbols yet? The less than, greater than, all that good stuff? Have we covered these?
I know what they are, but I don't know if we talked about it.
Okay.
They didn't know about like a vampire.
Yeah, we did. Okay. So, yeah, if you got vampire, I know I talked about. So the mouth, if you put teeth on it, follows the bigger meal. Okay. If we plot them on a number line, this is what they look like. I put 0 in the center. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to put 2 symbols on here that look similar. This is the infinity symbol, like Buzz Lightyear. It is not a number, but represents the idea of the largest number possible. This is strictly an idea. If you ever tried to give me a number and say it was the largest number possible, I could always add 1 to it and create a number that's 1 larger. So there is no largest number, but if there was a largest number, this would be it. So it's just a concept. Plus, the positive one means it's the largest possible one. The negative on it means the smallest or most negative number. I don't want to say smallest, because smallest sound like the smallest in any physical thing would be 0. You can't have like a negative distance. So, but 0 is not like smallest here. So let's say the lowest number, that's better. Smallest size, low is just a direction. So if I plot these on here, there's some things we need to know. If something has a greater than or equal than sign, or a less than or equal to sign, we use solid points on the number line. They're solid because of the equal part. Which means include that number. For greater than and less than without an equal sign, we use hollow points. To indicate up to this number. But don't include. Write all that crap down. So, with that in mind, numbers for set A, numbers that are greater than or equal to 4. So 5 is a number greater than 4, 10 is a number greater than 4. What we do is we put a circle on 4 and we fill it in. This is for set A. And we want all numbers larger than it. And you can do it on the number line, but I find doing it above the number line makes it a little bit easier to see, especially when you're drawing several. X less than or equal to 7 says find 7, which is right here, put a solid point because it's got the equal portion. And then I want all numbers that are less than it. So we use an arrowhead to indicate it keeps going. That would be set B. In set C, X is less than -2. They go more negative as we go less. So that's -1, -2. I'm going to put a circle at -2. I'm not going to fill this one in because there's no equal sign. But I'm looking for everything that's less than it. So that would be C right there. If you have the X on the left, this is pretty handy. If you have these where the X is on the left, not on the right, the alligator mouth actually looks like a fucking arrowhead. X is greater than 4, looks like an arrow pointing to the right. So it's got an arrow pointing to the right. X is less than -2, has an arrow pointing to the left. It looks like an arrowhead pointing to the left. So that's the direction it's going to go. X has to be on the left though. If it's on the other side, it's pointing the wrong direction. That's a quick, nice little shortcut into deciding which direction they go. That's just plotting them on a number line. I haven't put them in notation yet. So set builder and interval notation have two different ways of writing. Everyone ready? I know Michaela's not even paying attention. She's over here doing some chemistry bullshit.
That was your math. The question was that.
Oh. All right, so set builder notation. It's fucking dumb. I hate it. I'm going to rewrite set A and set B and set C. I'm going to use that graph in a second for the interval notation. So set builder notation, the corresponding set builder notation is, they will write set A, they will write like this. They will write this one as, it uses curly braces, then there's a giant vertical bar, and then they will say what everybody else just shorthands to without it. Set C. The way it's supposed to be read is what comes here is all values X. Then they have this vertical bar here. The vertical bar here is such that. And then the right side is exactly what it says. Such that X is less than -2. So your homework on the support quiz shit, support stuff will ask for set builder. They'll give you a lot of information, and then they will show you this part like this. And they will have a box here for you to fill in. Your job is just fill in this part. So for set C, that would be X is less than -2. It has more fucking characters and shit on it than is necessary. Annoying.
I have a question.
Yeah.
How come set A lost the equal to part? Greater than or equal to.
Because I didn't write it. Good question. I can get why that looks confusing. Yeah, it's literally everything you would just normally write as a way of reading it. They throw in these curly braces, they have this vertical line, and then they write this X. And I think just having the right side implies any number that fits this thing works. Any number that fits meets the all values X. It's implied in there. You don't need it. Alright, that's set builder notation. I will say no more about it because I don't use it. I hate it. It's a fucking waste of time. There's a lot of very stuffy math people that fucking wrote some stupid shit and it stuck for all time. They probably were people that did a lot of good shit, but then they used this weird fucking notation. And they're like, we don't wanna like get rid of like your contributions to fucking calculus and physics and shit like that, so we'll keep your shit around. I don't know why they use it. That's set builder. Interval notation is a little better, but has something I hate even more. So there are 4 ways you will see stuff. We will see stuff that has brackets on both sides. We will see stuff that has parentheses on both sides. Then you can see a bracket with a parentheses or parentheses with a bracket. Those are our 4 combinations. The way you choose between whether or not you use brackets are for less than or equal to or greater than or equal to only. The one on the left, you could actually treat that top line as the equal then sign, like that, and have a greater than or equal like that. They don't do it, but it's like that's if you like seeing like something that connects, that connects. The one on the right is like a less than or equal than sign. This is gonna make more sense when I use numbers. Parentheses are for hollow points and infinities. All right, so let's look at how these work on our number lines. Everyone got that? Like good with that? Okay. Let's come back up here and look at our set that we got. Set A. I think the easiest way to write set builder note or the interval notation is like this. Start on the left. And move right until you intersect your line. Until you touch your line. That's where you start the interval. Keep moving until you stop touching the line. That ends the interval. All right, so we're gonna do this here. I'm gonna do for set A. I'm gonna start on the left and I'm gonna go until I hit where set A starts. Set A starts right here. Set A starts at 4. It's the greater than or equal to part. It's got a solid point. I am going to use a bracket. I keep going and it goes all the way to infinity. The arrow, once I see an arrowhead, it means it keeps going. Infinities get parentheses. Set B. Set B, I start the number line and I hit the blue line right away. I hit the blue line at negative infinity. Infinities always get parentheses. I keep going until the blue line stops. It stops right there. It stops at 7. 7 has a solid point. The solid point represented in an equal portion. So the equal portion is going to give me a bracket. You do the same thing with set C. You get negative infinity and it stops at -2. But -2 has a hollow point, so it gets a parentheses. Let's add some new sets to this. I'm going to do set D, and set D is going to be, there's 2 ways of writing it. We can write it as A intersect B like that, or another way of putting it that I prefer is A and B. The intersection means it has to include both groups. So if I look up here on the graph, I'm looking for where both lines are. Both lines are from here to here. And we're going to have solid points for both of them because both lines have the included values. That's going to be my D. That D includes the blue line and the red line. Does that make sense?
What if B wasn't like hollow or A?
What?
If B or A weren't hollow?
We'll do one in a second that has it. So set D, if I write this, it starts at 4. It ends at 7, but it include, I'm off the page. But it includes both points. Let's make another one. Let's call it, so that was D. We'll call E where B and C are. So if I come up to the picture, the B is my red line or blue line, C is my left red line. The values that work here, they start at the left. And they go all the way up to C. Shit. But C is hollow. So C doesn't have a value there, so we're not including that value. So, oh, I'm off screen. Set E looks the same as C. It equals set C. So we would use the same notation. It starts at negative infinity and it goes up to -2. And it stops and it doesn't include -2, so we'll use a parentheses.
Wait, so like, why did we remove set B?
What?
Why did we take out B from that equation?
Because we want it where it's both lines. And C doesn't have any portion over here.
Oh,
So like if we look at the green line right here, it actually looks identical to the C line. And that was B and C. Another way of writing B and C is B intersects C. I don't know which way the homework's gonna do. Probably the intersect symbol. Because they like confusing the shit out of students. Now the one that looks quite a bit different. Let me move this down where I have this at the bottom. If it is if I do set A or C. So we'll call F. That's the same thing as A or C. Which is the same as A union C. Now it needs to be on either red line. So if I do the pencil thing on the red lines, I start at negative infinity, which gives me a parentheses. I go up to C and I stop at -2. -2 is a hollow point, so I'm going to use a parentheses. And I'm doing A or C. This region right here doesn't have A or C, but when I get to 4, A starts up, so I'm going to include 4.
the brackets.
And it's brackets here. Excellent. And it keeps going to infinity. So if you just move the pencil left to right, you can literally write them down in the order you see them, which will keep the order correct. if you have more than two like groups here, what you have to do is say in union here. So that would be interval notation for A or C. Oh. Something else I want to show. For the set builder notation, this set D and set builder is between 4 and 7. We would write this as we would have 4 less than or equal to X less than or equal to 7. And the only way to write A or C in set builder notation is X is greater than or equal to 2 or X is greater than or equal to 4 or X is less than -2. That would be set builder notation there. They might put it in a different order. You could have X is less than -2 or X is greater than or equal to 4. So being able to read these and knowing what numbers are being talked about is helpful, and they switch between them. So something to note here on this one. As you go from left to right, it goes from lowest to highest. Interval notations all read like that. Lowest to highest from left to right. You would never, ever, 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 ever write the 4 to infinity before the negative infinity to the -2. That's the wrong order. They need to go in this order. Couple more ones we can look at with this stuff. I'll keep using this number line. I'm at the top of the page. Let me come up here and put it like that. Let's do A or B. A or B. Just the same thing as A union B. I want wherever it hits the blue line or the A red line. This starts at negative infinity. And infinities always get parentheses. And it goes all the way up. It gets to 7 where B ends. But A has already started, so we continue along with A. And A goes all the way to infinity. So it's negative infinity to infinity. There's a couple ways they'll say this in set builder notation. They could say X is a real number. You could say negative infinity is less than X, is less than positive infinity. And another way they write the top one, they do an X. They do this weird like C with a line in it. It looks kind of like an E, but not really. It's a fucked up E, like a rounded E. Literally looks like a C with like a tongue sticking out. And they'll do an R like that. Sometimes the R has an extra vertical bar. That means the R is for real numbers. What they're gonna want on the homework, you're just gonna have to find out. I don't know. If we look at A intersects C, we get a different story. A and C, which is A intersects C. The and means both lines need to be touching it. It needs to overlap both lines. But A and C do not cross. A and C don't cross, which means there is no value or no solution. The words they'll use for this are empty set. They might show a 0 through a line for it. And another way of showing the empty set is just doing empty braces. But there is no interval for this. Let me give you guys some practice. For you to try. Set J will be X is greater than -1. Set, I don't have an H yet, do I? Set H will be X is less than 3. Set K will be what do I want to do here? X is less than -4. And set L will be X is greater than 5. First off, write interval notations for these. Then do H in union with L. Maybe I better throw an equal sign on one of these. Put an equal sign on H and let's put an equal sign on L. Then do H union J. And H intersect J. I'll give you a few minutes to go over that. And then we'll do it together. And that will be it for today. Forgotten that the doctor at the hospital told you that it was literally killing you. Say anymore, but I wanted to give you another nudge in the best direction for you. Trying to treat drinking like he's going on prices, right? Going over the price. All right, let's do this together. I drew the picture of the arrows real quick. So H starts at negative infinity and it ends at 3. 3 is included, but infinity never is. J starts at -1 and goes to infinity. Infinity is never included, and J has a hollow point, so it gets parentheses as well. K, it's down there, it's my red line. It starts at negative infinity and goes up to -4. Negative infinity is always a parentheses, and -4 is a hollow point. There's no equality, so it's a parentheses also. L starts at 5 and goes higher, all the way up to infinity. And 5 is included, so we're going to use the bracket. H or L. H or L. H, so this is wherever a blue line is. The blue line starts at negative infinity. It goes up to, I put my dot in the wrong spot. That should be right there. Oh. It starts at negative infinity. It goes up to 3. And then there's a break and it starts again at 5 and it goes to infinity. The infinities always get parentheses. 3 was a solid point. We also have the equal portion, so it gets a bracket. 5 was a solid point. It had an equal sign. It gets a bracket. And since there's 2 regions, we need to put a U between. If I look at H union J, or H or J, it's wherever either of these 2 lines are. That starts at negative infinity and ends at positive infinity. So that's interval notation for that. Just bring nothing to write? Or do you already have your backpack in here?
I usually type everything.
And then H intersect J. H intersecting J is only right here. It starts at -1 and it goes up to 3. The J has a hollow point, so it gets a parentheses on the -1. Both of them are touching the 3 part though, right here, that's hitting 3. They both hit 3, so we're gonna have a bracket for that one. And that one's like saying -1 is less than or equal to X, it's less than or equal to, sorry. -1 is less than X, less than or equal to 3. This one is like X is less than or equal to 3, or X is greater than or equal to 5. All right, take a little break.